All right, good morning.
Morning.
My name is Kiran Pathakoda, and I'm a program manager on the Bluetooth team. So welcome to the Bluetooth session for Build 2015. I'm so glad you guys came out. I hope you all knew that there's a HoloLens session going on at the same time as this. I really appreciate you all coming out. So today's session will be really fun. We're going to go through the new features and APIs that make Bluetooth great on Windows 10. We'll take a closer look at the APIs and see how you can integrate them into your existing apps. Finally, our partners, one of the early adopters of our APIs, Footmarks, is going to come out and share with you their experience developing on Windows. But first, I'd like to share with you why I think right now is the most exciting time to be a Windows developer using Bluetooth. And even before that, I'm going to ask you to please submit an evaluation. This will help us tailor the experience for next year, so be sure to do that before you leave. All right, thanks. So there are 3 reasons why I think right now is a time of great opportunity for all of us. Reason number 1, sheer market. Since the early days of Bluetooth, when it was simply an audio pipe, it's come a long way. Nearly ubiquitous in the car. And a current estimate actually put Bluetooth shipments in 2015 at over 3 billion peripherals. That's huge volumes. Reason number 2, for ISVs out in the audience, Bluetooth is being used in new and compelling ways all the time, so new scenarios are being enabled. We've seen Bluetooth Low Energy in almost everything, fitness, wearables, and health. And as we've seen in the past, new scenarios means new opportunity for developers to realize that vision. Case in point, we had the Microsoft Band that came out last December. A brand new app ecosystem because they previewed their SDK earlier this year. The brand new ecosystem that's ready for all of you to party on. That's opportunity as well. And reason number 3, some of our IHVs in our audience might shake their heads, say yes. And this is really important for all of us developers. And that is that with Windows 10 and the rise of the Universal Windows platform, we will have the largest number of Bluetooth-capable Windows devices that we've ever had in the past. So you can deploy a single app or a single driver to all of these phones, PCs, and tablets. Just looking at current upgrades, that's hundreds of millions of Bluetooth-capable devices. So that's great as well. So these 3 reasons, sheer volumes, new scenarios coming out all the time, and hundreds of millions of Bluetooth-capable Windows devices cause me to say that this is a great time to start developing for Bluetooth and the best time to start developing for Windows. One of my favorite stories of a group of developers that's been able to take this sort of opportunity and really run with it and deploy a solution that impacts people's lives is the Cities Unlocked project, sponsored by Guide Dogs UK in partnership with Microsoft. They took a unique problem faced by the visually impaired, that they're not able to navigate new parts of the city, and they have a unique solution. So please allow me to share a very short video to show what they did.
Bill, Thomas and Connor are at their local train station. Bill's phone has automatically coupled with the local train station system and provides him with all the information he needs regarding platform, departure time, and any other news. As the group wait for their train, Bill receives an alert. The alert gives him the exact position of his train carriage doors, and as the group moves to the right spot, their train appears right on time.
Take 2 paces forward. Your carriage is H. There is a slight gap and step up into the carriage.
That was an awesome use of technology. Yeah, you can clap. They're doing a great job in the UK. And so that was an early concept video, and since then they've made larger strides forward in other technology as well, even involving a bone conducting headset that gives their users 3D sound perception. It's incredible. But the Bluetooth use there is that they have beacons placed strategically along the city that broadcast the object's location. And we'll talk a lot more about this technology as the session moves forward. To deliver this sort of opportunity to all of our developers, Windows and Microsoft had to deliver on a vision that was conceived in early 2011, that of a converged operating system. For a platform team like Bluetooth, that meant in Windows 8, Windows Phone 8, we delivered a converged radio driver. Started with the basics. And as some of you may know from last year, Windows 8.1, Windows Phone 8.1, we delivered a partially converged API surface. The background functionality was still not on Windows PC. And finally, I'm so proud to say that in Windows 10, we have a completely converged API surface that works not just on Windows and Windows Phone, but on all of our devices, from small form factors like IoT devices and Raspberry Pi 2 to larger form factors like the Surface Hub. And our engineering improvements didn't just stop there. Our revamped feedback system will allow us to get actionable and unique insight from our self-hosters faster and easier than ever before. I was actually one of the program managers, one of the members of the Bluetooth team that had the pleasure of reading through all of your feedback. And I thought it'd be fun to actually put up some of my favorite quotes on the screen for you. Some of these might even be yours. Some of our feedback was immensely positive and really validated the work that we put into Windows 10. Some of it was not so positive and showed us that there's a long road forward for Bluetooth specifically. And we're looking to our other engineering improvements, like Windows as a service, to be able to deliver on features faster and with better code velocity. Some of the feedback was immediately actionable. A lot of you asked for a quicker way to turn on Bluetooth. We made sure that Bluetooth was in the quick action setting, even on desktop. Finally, we had feedback from all over the world. This one in particular was from Indonesia. Had no idea what it meant, but through the magic of Bing Translate, you realize that Bluetooth connection problems affect us all. It's a universal problem. Thank you all for being with us since throughout Windows 10, and we look forward to your continued support as we develop on future releases. So, with all of our engineering improvements, Windows as a service, and revamped feedback system, what's new in Bluetooth for Windows 10? I'll tell you, we've delivered on a broad range of feature areas in Bluetooth. We have audio features like aptX and wideband speed support. We have core spec updates. Windows 10 will be core spec 4.1 compliant. Finally, my personal favorite, being able to use my Bluetooth keyboard with my phone to type up a long email. Bluetooth HID for mobile is on Windows 10. Couldn't be more excited. But there are 4 features up here that I hope catch your eye. Not just because they're bold, large, big font and strategically placed on the screen, but because they're new and they enable compelling new scenarios. I'm talking of beacons, broadcast, and being able to do this in the background, taking advantage of our new hardware offload capabilities. So let's double click and understand a little bit more about each of these. First question, what is a Bluetooth LE beacon? Well, beacons use the advertisement packet. Now, I'm not talking about the advertisements, like Mad Men style that you watch on TV, consumer ads. I'm literally talking about the advertisement packet that's been in Bluetooth since Bluetooth Low Energy. It's a unique payload that's advertised. The value proposition of beacon technology is that you can take this unique payload and give experiences to the user. Experiences like presence detection. As we saw in the earlier video with Cities Unlocked, the presence of a bicycle rack beacon or the presence of a train beacon pulling into the station surfaces unique experiences to the user, location experiences, for instance. So that's really powerful. In addition to just presence, you want to know whether the user is close to a beacon or further away. So in Windows 10, you get the received signal strength, or RSSI value, of every advertisement packet received. All right, I know a lot of you are happy. And finally, Windows can be the beacon as well. With our new broadcast APIs and publisher APIs, you as developers have the power to actually input what's being advertised by Windows. And this is great as well. So to enable all this functionality, we knew this had to be great in the background as well. And we can't live in a world, we can't have experiences for the customer where they're constantly disturbed by stuff that doesn't matter to them, or that they experience power drain just because they walk into a room crowded with beacons. So for that, we worked with our IHV partners more closely than we've ever had to in the past. Working with them allowed us to develop an experience so that you as developers can write to an API that communicates all the way down to the controller. So the controller actually makes decisions on which packet to keep, which advertisement packets to keep, and which ones to throw away. This level of cooperation has never been done on the Bluetooth team. And I'd really like to thank all of our IHV partners for participating in this throughout the release. The work they've done is going to enable really cool, power-efficient experiences for all of our users. That's great. So for all of these features, we had to make 3 major namespace updates in Windows 10. We're going to move into the more demo section. We're going to learn how these APIs function. So Bluetooth.advertisement, completely new namespace, houses our powerful watcher and publisher capabilities, so Windows can listen in and broadcast. Bluetooth.background got a facelift, completely converged in Windows 10, and houses the new trigger details classes so that in the background task, you can actually read off the trigger details. And finally, because the Bluetooth background affordances just hook into our existing background task capabilities, all the new triggers for watcher and publisher are in application model.background. All right. So on to the fun stuff. Let's learn how to actually implement this in your app. Before I step into Visual Studio, I just want to solidify 2 topics. And we've talked about it just briefly now, but the advertisement watcher and the advertisement publisher. The advertisement watcher will usually sit on a phone, PC, or tablet and listen in to beacons. There are only 3 steps to setting up an advertisement watcher. Configuring with filters, so telling us which patterns to look for in order to get what's interesting for the user. Attaching your event handlers so that you have a response to receiving an advertisement event. And simply starting the watcher. Once you start the watcher, Windows is listening for beacons on your behalf. Then we have the advertisement publisher. A couple quick notes before I actually go into how to configure this. The advertisement packet is only 31 bytes, and it's a system-wide shared resource. So it has to be used carefully. We have a couple of remedies for this, which I'll discuss. So you have to respond properly to status change events. But we've really envisioned these APIs for single-purpose, focused use cases, like embedded devices, point of sale, which is shown here. We realize this is a limitation, but we're working on solving this in the next couple of releases. To actually set up an advertisement publisher, there's only 2 steps. Configure it with a payload, super easy step, and actually start publishing. And once you get the callback from one of our events, from the status change event, Windows is advertising on your behalf. All right. So in this demo, I hope to accomplish a couple things with y'all. 4 things. We will learn how to set up an advertisement watcher. We're going to learn how to configure a payload, publish advertisements. We're going to do all of this in the background so that users so that the beacon advertisements will survive through multiple reboots 6 months from now. And finally, we'll have a little fun with Azure, and we'll integrate with Azure. So let me switch over to Visual Studio. And we're going to go through this. Great. Have you seen this? Okay, perfect. Before we even get started developing for Publish and Watcher, just the fact that you're using Bluetooth necessitates a device capability. So be sure to declare device capability Bluetooth in your manifest. Now, the way I set this demo up is I downloaded what we had on GitHub. So if you have trouble following along, we're going to cover a lot of ground in the next 20 minutes. Be sure to go download the app on GitHub. It's really well commented. I had to strip a lot of the comments out, so it's easier to read. But a lot more detail is explained there. And then I added the Azure scenario. First, we're going to look at how to actually set up a foreground watcher. Like I said before, there's only 3 steps: configuring the filters, attaching event handlers, and starting the watcher. So let's go through each of those in a little bit more detail. So in the constructor for your page is where I usually like setting up the configuring the watcher for filters. And there are 2 main filter types in Windows 10. The first one is a payload filter. So you can actually code what pattern to look for. In this particular example, I'm just using the manufacturer-specific data to code my filter. But you can use any part of the advertisement packet. There are a couple of other SIG-defined ones. There are 2 fields underneath the manufacturer-specific data that are pretty interesting just for beacons in general. And that's the company ID and the actual data. The company ID is assigned by the SIG. And there's a big web page with a bunch of company IDs, and you have to go register with them. But I'm choosing an unassigned company values just so I don't offend anyone. Then I have the payload that I'm looking for. Simple pattern, 1, 2, 3, 4. Just keep that in mind as we go on to the publisher demo. The second type of filter is a proximity-based filter, so based on RSSI values. I found that anything above -50 dBm is pretty close to each other. It means the 2 devices are close to each other. Something lower than -100 is usually far, but your mileage may vary. So be sure to test with your specific implementations of beacons and your app while setting these filters. So this is a little bit more experimental for you all. All right, so now we've configured the watcher filter. Let's go on and see how to configure the event handlers. Oh, okay. Now, the Bluetooth advertisement watcher has 2 events in Windows 10, the received event and the stopped event. Received is triggered every time you get an advertisement packet that conforms to your filter that you defined in up above. And the stopped event is really great for troubleshooting your user experience. So in case the Bluetooth radio is not available, the user inadvertently switches it off, your app will actually stop functioning and will stop watching. So implementing this event, a custom event handler, will help you catch those problems. But I'm going to go ahead and only implement the advertisement received, because that's the interesting one that you can use to modify your functionality within your app. So when I receive an advertisement packet, okay, it's a pretty involved code snippet to look at the beginning, but all I'm doing here is casting. Whoops. Give me a second here. Okay. I'm taking the Bluetooth LE advertisement received event args. So the event args, and then reading off properties from all of them. And that gets you all the unique characteristics of your advertisement packet. So what you see here is I'm getting the timestamp. So when Windows receives the advertisement type, this is SIG defined. It's a combination of connectable, non-connectable, or directed and undirected advertisements. So that's SIG defined advertisement types. You get your RSSI values, which is used for proximity scenarios. And you get the local name, which is a portion of the advertisement packet as well. The the stuff that I'm really reading off of is the manufacturer-specific data as well. And so all I'm doing here is printing all these properties to the screen. But of course, within your app, you can use this to enable more cool scenarios. So now that we know, we've configured our filters, we've gotten our event handler set up, there's only one last step. When the user clicks the Run button, we just need to make sure to start our watcher. So Windows will start listening once the Run button is clicked on the page. So let me go ahead and deploy this. It's going to build. All right, so we have the foreground watcher. So when I hit my Run button, we do get advertisement packets. Huh. I was actually not expecting this. One of you might be running the sample on your devices. But it looks like we already have an advertisement packet that conforms to our pattern. If you look here, the company ID and the payload matches the filter that we're looking for. And we've gotten a lot of advertisement packets. All right. So that's the foreground watcher. To implement the other side, we need to set up the publisher demo. So let me go and show you how to set up the payload. It's the foreground publisher scenario. Publisher, there's only two steps: configuring the payload and actually starting the publisher so Windows advertises on your behalf. Okay, so the constructor for the publisher. Okay. Now, this code looks pretty similar to the earlier code in the watcher filter configuration. And that's because we use a container advertisement class. So that's just a general class that you'll use. The main difference for the publisher is that we only allow you to write to the manufacturer-specific section, as well as any unassigned values. So in the watcher, you can configure filters based on anything, based on the local name, based on flags, stuff on that order. But for the publisher, you can only write to the manufacturer-specific sections, the company ID, and the data in particular. And now that you've configured your payload, and notice that I'm taking care to have the same pattern as what I'm watching for, we can go ahead, and when the user clicks the Run button, I'm going to start the publisher. All right. Now, there's a sort of step 2.5 to this whole process, which is you want to troubleshoot in case that you are not properly resourced by Windows. As I said before, 31 bytes is a system-wide shared resource. So there are cases where other apps in the system are using the advertising packet already. And so you, to make sure that you know that your app is not being serviced by Windows, we have a publisher status changed event. And implementing the custom event handler for that will allow you to catch these situations. Catch if there's not enough resources, or your advertisements are just waiting. Things on that order can be done in this, with this event. All right. So now we have two scenarios. The fun thing about this being a universal app is that now I can actually change my architecture and deploy to my phone. So I'm gonna, now the emulator, oops. Okay, so the emulator, you can totally build and deploy Bluetooth apps to the emulator, but it doesn't come with a Bluetooth radio. So what'll end up happening is all the Bluetooth functionality will look like it doesn't exist. So I'm actually using a real phone. We have a cool app, project my screen, and just projecting it to the to my laptop. And so we have the publisher sitting on the phone. What's odd here is that there's already advertisements. It's okay. I'm going to run this anyway. So when I start running, I'm going to start the foreground publisher. You know what? I might actually have a background process running on my other app. Just give me a second here. I doubt any of you. Are any of you running the app on your screens? No? Okay. Let me check once again. If this doesn't work, we'll just give up. All right. All right. Someone is clearly running this app. So you can see the publisher is working for someone else. But as soon as I run the publisher on my phone, I'm also presumably publishing the same advertisement packet. You know what we can check is the RSSI value. This will be interesting. So I'm going to take my phone. I'm getting a lot of these advertisements. OK. And we have to navigate to the lowest. OK. We're getting -40, so the devices are really close. -38. Now if I move really far away, we get into the 60s, 61. If I move to the back of the auditorium, we might even stop receiving advertisements because of our filter. But yeah, that's the publisher on the phone. So now you know how to set up a foreground watcher, foreground publisher. But often, you'll want beacon functionality past reboots and for users 6 months from now. So we have to learn how to do all this in the background. It's very similar, a very similar programming style, except now we're involving the background task capabilities. So let's move into scenario number 3, the background watcher. All right. So the background watcher initialization is very similar to the foreground case. And the main difference, there are two, I'm not going to say restrictions, but there are two capabilities in the background. The first is that for the payload, there has to be one and only one payload filter. This is because we want a power-efficient experience for the users, as well as a focused experience, because you're going to launch a background task, do something critical and interesting, and then close it. So it's going to have one and only one pattern. The other major difference is that your sampling interval, the minimum sampling interval in the foreground is actually 0. So you get every single advertisement packet. In the background, again, in the interest of power efficiency, our minimum sampling interval is 1 event a second. So you're guaranteed an event per beacon per second. But if you have multiple beacons, you'll actually get more advertising packets in that vicinity. So another difference, we're using the watcher trigger instead of just our Bluetooth LE advertisement watcher. And now we just have to do some basic background task type things. We define a task entry point, so it's a fully qualified class name, namespace, and name of the class with capitalization and everything. Be sure to do that. It's just one of the common gotchas. And then declaring our background task in the manifest through an extension capability. We've done some work in Windows 10 to actually simplify the developer experience. So we've consolidated a lot of our old background task types to one single one, Bluetooth. Once you've declared, we've configured the trigger, task entry point, and declared it in the manifest, we want to have the user press the run button and register a background task. Again, some fairly involved code, but still doing a simple operation. We're going to check if a previous task has already been registered, and there's some code above that actually does this. Be sure to look at the sample on GitHub. And then we just build our background task from the previously configured trigger, as well as the task entry point, and try and register it when the user hits the run button. Now, there's a number of reasons that background task registration can fail, but the one special case is if the hardware is actually not supporting our new hardware offloaded feature. As we talked about before, we actually worked with all of our IHV partners to enable this. But a lot of our devices currently may not be upgraded to support the feature. The good news is all the new Windows 10 phones and a lot of our major flagship devices, including the Surface Pro 3, will all be upgraded to have the feature. But you'll have to take care of this exception in case a user installs your app on a device that does not support hardware offload. Okay, so now that you've taken care of this exception, your background task is presumably registered. And because all of you might not have hardware that supports it yet, I'm actually running this on the same device that was given out to everyone, the HP Spectre. We have a special preview API that we're demoing here, which enables software filtering. So even though you're not running it on a device that actually supports our feature, the hardware offloaded feature, this will all work till Windows 10 officially releases. At that time, the preview software filtering feature will be removed, and this exception will start being caught by your app. So be sure to do this in anything that you're coding up between now and release. All right. So now, presumably, the user hits the run button, your background task is registered. But what happens every time you get the trigger? Well, then we have to go to a separate project that houses our background tasks. I'm not going to go into too much setup of background tasks, but there's some great sessions that were on the first day. I think Sean Henry had a session that talks really well about background tasks. And I've linked to some of them at the end of the session notes. But when you get the trigger, we're going to do a very similar operation to the foreground, which is read through the advertisement packets and display properties on the screen. That's all I'm going to do in my background task right now. But there's one major difference between the background and the foreground. And that is, because your task may not fire every second and satisfy your minimum sampling interval, we'll actually aggregate multiple advertisement packets into one trigger details. So what I'm doing here is casting the trigger details as our type, so as the advertisement watcher trigger details. And then, like I said, the main difference in the operation is that now you have to, instead of just reading off the properties directly, you have to go in and loop through all the advertisement packets that might be contained in your event args. And once again, all I'm doing is reading off the timestamp, the advertisement type, and so on and so forth, and printing it to the screen. This is where you might want to raise a toast, perform a location type operation, things on that order, but I'm going to print to the screen. And the cool thing about now having this in the background, so let me go ahead. I like using my phone as the publisher and having my PC as the watcher. The great thing about having a background task for the watcher is that I can close the app and come back to it. Background task is still registered. So the foreground watcher, so I come back, it's not going to be running. And when I close it, of course, it's not going to be running. But the background watcher, as soon as the event gets registered, as the task gets registered, you'll see, sometimes you'll see multiple event counts if there were multiple devices in this vicinity. But then when I close the app and I come back to it, I'll still see my background task registered. So you'll keep getting those events. So that's the beauty of background tasks. And now we're going to do a similar application for the background publisher. So the background publisher, very similar to the foreground. It's basically combining your foreground publisher with your background task capabilities. So I'm going to gloss over a few of those operations now because you just saw it with the background watcher. Right, so I'm going to configure the publisher, the advertisement payload that I'll be broadcasting. Looks exactly the same as the foreground. And then again, do my special background task type things, define the task entry point, declare it in the manifest, and then when the user hits the run button, we do a similar operation to the watcher and build out your background task with your previously configured trigger and the task entry point. Now this is similar, so the triggers in the background are similar to the events in the foreground. So you can think of the watcher events received and stopped as what's going to trigger the background task. Similarly, the background task for the publisher is triggered by status changed events. So the first time you register your background task, the first time the user hits run, your background task will be called once because it's going from undefined status to started or waiting. And then future publisher status changes will be reflected in your background task. So that's usually what I use in my run method. All I'm going to do here is print out errors to the screen. It's great for troubleshooting to make sure your app is constantly publishing. Once you get the event that your publisher has been registered, Windows is advertising on your behalf and will continue to do so even when the app is not in the foreground. I strongly suspect I had a background task running on my phone this whole time, which is why we've seen advertisements the entire time from the beginning. So I'm going to deploy this to my phone, and we should have the publisher background task scenario running on my phone. So here goes. Whoops, excuse me. All right, well, the demo gods are not being kind right now. Let's do this. I think I may have started deploying too soon. Perfect. All right, so we have the background publisher. So this would be cool if I could show you the, when I publish in the foreground, the advertisements will start and stop when the app is not in the foreground. All right, so we're going to have the watcher started. Wow, and we're not getting advertisements now. I think our background task got overwritten. Okay, so in the foreground, when we advertise, you see the advertisements start on getting seen by the watcher. But as soon as I close the app and navigate back home, the advertisements stop. There are no advertisements being seen anymore. However, if we go in and launch our background publisher, our background task gets registered. And as soon as the background task is registered, you start seeing new events. Note the timestamp, right? Okay. So we're getting new events. And even when we go, when we close the app won't even be in the backstack. We'll still have the background task continue to run. And you'll still see advertisements. Once again, the timestamp's incrementing. All right. So it's as simple as that. Watcher, publisher, being able to do this in the background. But let's have some fun with this. As users, sometimes it's really useful to get more context. I don't just want to know the payload, and it's pretty tough to give your user all this context that the beacon can have just simply through the 31 bytes. Microsoft has a cool service that allows you to ping the cloud and get back more context for the user. So let's move into our Azure integration demo. All I'm going to do here is take the first scenario, so the foreground watcher, and instead of displaying to the screen, right, and remember the same payload, so 1, 2, 3, 4, I'm looking for the same pattern. Instead of displaying received advertisements to the screen, I'm going to match that payload, send it up to Azure, and return a string and get more context for the user. A simple link query and integrating with Azure Mobile Services will allow me to do this. I've linked to the tutorial for how to add Azure Mobile Service capability to your app in my session notes as well. So I'm going to deploy this to my PC. All right. Simple link query just to match the payload, send it up to Azure, and match against my table up there. And so when I run my foreground watcher, you see the same company ID and payload, 1, 2, 3, 4. all I'm doing in the Azure integration demo is taking that payload, and it's going to ping up to Azure. Let me actually show you this all real. Here's my Azure table. It's my actual subscription. I've got a lot of stuff going. So when I get this payload, I'm going to return this text. The internet. Let me get this started. Sometimes it takes a little bit of time. Let's see if it's still advertising. Okay, I'm still getting advertisements. Come on. The last part of the demo. It's always the kicker. All right. Let me see. I'm going to make sure I still have a payload up in Azure. Yeah, I do. Let's debug this up just for a second. Rerun the app. Okay, looks like I'm not able to show you being able to receive. Oh, there it is. Yes. So you get the advertisement payload. And you match it up to Azure, and now you have more context about the device. It is, in fact, a bicycle rack. All right. But let's say you deployed all of these out into the field. And instead of embedding them in bicycle racks all over the world, they've somehow made a snafu in the manufacturing area. They're actually configuring it. They actually put it into a different device. Well, what do you do then? Do you go in and have to flash each of those individual beacon firmware? No. You can reconfigure Azure to get the payload and return something different. In this case, I'm going to go to my super fancy Azure Management Console and reconfigure it, because they put it in lampposts all over the world. I don't know why they did that. Makes no sense. F8. Hopefully reconfigure this. And then, looking at the same payload, right? Company ID and 1234, we're going to match up to Azure. And now your bicycle rack is magically transformed into a lamppost. And this is awesome type of, thank you. This is great functionality. A great example of a company that's taken this idea and really run with it and been able to deploy an enterprise-ready beacon solution is our partners, Footmarks. And please join me in welcoming up CEO of Footmarks, Todd Paris, onto the stage. Todd Paris.
I don't think I've ever seen anyone so excited about a bicycle return. That happened there. So I think my job is considerably more easy than Kieran's with all the coding. But when you look at the work he did, the good work he did, and you think about the gigantic and obvious mobility global trend on the consumer side and on the business side, it's clear there's just a ton of value to be created by all of you as developers and us as Footmarks. So at Footmarks, we saw that a while ago and got pretty excited by that. So we're kind of really looking forward to Windows 10 rolling out to all the billion different devices. And there is tons of opportunity for everybody. We also know there's tons of challenges. The number one challenge there is on the consumer side. We need consumers to engage in the ecosystem. So if you go into your app and you turn Bluetooth off, you go dark effectively, and this ecosystem can start to whittle down. So we need, as developers, to make sure that we do create value and share value using this cool technology so they stay engaged in the ecosystem. And at Footmarks, we have this one term we call, it's the yellow shoe challenge. Basically, if I'm standing in the real world and I'm staring at a yellow shoe, as developers, know that I'm staring at a yellow shoe in real time. So talk to me about the yellow shoe. Not a minute later, not as I move 12 inches to the right. When I'm standing, staring at that yellow shoe, talk to me about that. And even better is know who I am. Use my online personas, purchase data, but know who I am. So when I walk into any physical location, you can proactively start to find the things that are of value to me, this organic proactive search in the background. and then bring that back to me. Help me find that product in any physical location. That's where true value starts to get created. And we work very hard at Footmarks to make that happen. And when you do that, good things will start to happen. Massive developer opportunity. And really the one word I'd sum it up is monetization, the way to make money. When you do it well, this will happen. We've deployed at NFL stadiums, retail centers, and malls already, and you can start to see good things happen in the app stores and with your app. The number one thing is increased app downloads. So people know they're going to get more value with BLE from their apps. So 6 to 7 times more downloads of BLE-enabled apps than non-BLE-enabled. And that's huge. That's a massive number. App engagement. So session durations start to get much longer. And the best way to think about this is, in the traditional world of digital media, online advertising, in mobile ads tend to have click-through rates of less than 1%. Less than 1%, and not very impressive. But with BLE-enabled ads, so this is just standing in front of the yellow shoe, maybe I get an ad for a yellow shoe, that number moves to 20 times and 60 times. So it's orders of magnitude, much better engagement you start to see. And then when you have more downloads, more value being created, that flywheel starts, and you start to see really cool things happen, better ratings, and around this virtuous circle you start. So it's clear there's a massive opportunity, especially when you keep in mind the Windows 10 and that massive scale that we'll start to see going forward. But let me back up real quick. The reason I'm here is just a quick demo, but at Footmarks, we were lucky enough to get involved with Microsoft about a year ago. So we're the only BLE company that started to consult with them as they started to develop their solution. So in addition to having all of the classic or cool features of BLE, we, as a startup, needed a few additional things, which is make it easy to use. As a CEO of a tiny startup, I don't have a ton of resources. So I need to make sure everyone is really working well and really quickly. And that was what was really cool about what they did. It took us just a matter of hours to port over our Android code, point to the Windows 10 SDKs, magic started to happen, and we started to get the contextual returns that we expected to see on the Windows platform. So I think that was an extremely cool thing for you guys to do. Yeah, much appreciated. So that was kind of the big, easy thing to do for us. And that brings me to the demo in particular. So we have 3 different things happening, and Kieran was talking about them. I'll touch on them real fast because the demo is kind of brief. So in the background, you'll see the beacon broadcasting the advertising packet, and you'll see the SDK, the phone seeing, reading, and watching, talking to Azure, the ping back, and then the actual payload return. So we'll move into the demo here. On the payload note, Kieran, we've been watching Kieran. We actually put a beacon in Kieran's office, and we enabled his boss's phone with our SDK, and we enabled your phone with your SDK.
Really?
Yeah, really. Yeah, and so we saw over time, Kieran has a little bit of a hard time getting to work in time, especially relative to his boss.
That's true. It's a constant struggle.
Bonuses are coming. It's a little hairy. So we had an idea. Why don't we actually start to give notifications to Kieran when his boss gets near the office, and then race real fast to the office and save his job.
I'm starting to see how the privacy invasion is starting to pay out.
There's a value. There's a
there's
value.
a value
I'm
to
telling
the
you,
whole
there's a
thing.
value.
Okay.
So the idea is if he actually gets in time, it's perfect. He's happy, fully employed, might even have a bonus at the end of the year. If not, then that's his boss, his evil boss, yes. In that case, maybe you're unemployed or tiny little bonus.
Probably after what you just said.
Yeah, exactly. So why don't you log into the app? And so what we've done is we have a beacon out in the middle of the audience. And so this is pretty similar to the setup that we have in his office. But effectively, that beacon represents your office.
Okay.
And what we'll do when you log in there, we'll start you on your peerless journey towards the beacon to see if you actually got there in time and see if you actually made it in time. So we'll start the demo.
Are you trying to sell me something, Todd?
Yeah, we'll see if you actually get there in time as you're approaching. We'll see. Let's hope. Notification.
I think I'm going to make it.
And let's see.
Oh,
We're
boy,
not
this-
so sure.
Oh, man.
Unemployed. You're now unemployed. So ladies and gentlemen, here's a developer that's unemployed if you're hiring. Yeah.
I thought I was going to make it the whole time.
Yes. We kind of had a little bit of fun with Kieran, but the reality is that with the platform they put together, the ease of use of the tools, the matter of fact, it took us just a few hours to port over our code, and you think about that scale. I think at the keynote it was 1 billion devices that is the goal for 1 or 2 years out, that's a massive number, the upgrade path to Windows 10. So this is a great tool set. It's massive scale for us. So we're excited to bookmarks, definitely. So with that, I'll pass it back to Kieran. I am also reminded, come visit us at the Insiders Lounge at the completion of this. Kieran.
Thanks a lot, Todd. That was great. So as Todd just said, do you have the clicker?
Yep.
All right. So as Todd just said, I'm really glad he said it, we at Microsoft have worked hard to make it easy for you all to use this technology. We've made it easy by unlocking the opportunity of hundreds of millions of Bluetooth-capable Windows devices. We've made it easy by converging our API surface, so you only have to write one app or one driver. We've made it easy to integrate with Azure and deliver a power-efficient experience through hardware offload. So go forth, engage with our APIs, give us feedback, we're listening. And if there's one message I hope you'll take away from this entire session, it's that the technology is no longer the limitation. Our creativity will unlock the potential of beacons. Thank you all so much for attending the Bluetooth session. Before I take questions, I just want to say that Todd, myself, and one of the primary designers of the Beacon APIs, Alex Sung, one of my colleagues, will be out in the Windows Insiders Lounge. So come by and see us afterwards. There are a couple of related sessions I'm just going to click through. We have the app model. So I think they talk a lot about, oh, I did not switch back to the PowerPoint. You were looking at George the whole time. Beautiful. There's a couple of related sessions with the background tasks and stuff. Andrew Klinick and Kyle Marsh gave a great talk on Monday. And as we talked about with the huge opportunity with Bluetooth development, here's the Microsoft Health Band related session. And with that, I open the floor to questions. How much time do we have? All right, so we have time for a few questions. Please come up to the front. There's a mic right here. I believe that's active. I don't know if there's another one. Go ahead. Yeah, can you speak to the mic, please? I think it's being recorded, so it's just easier that way.
Yeah, I've been using beacons for quite a while, and one thing that kind of bothers me is you guys are sort of not following what everybody else does with iBeacons, it seems like. For example, whenever you're looking for beacons, there's two established methods, right? You can monitor or you can range.
Okay.
And I only saw one, which I think is equivalent to ranging for a beacon. There was no monitoring or anything, which is considered to be better in background mode, right? Because you use less power. The other thing is, I mean, we're talking about the advertising packet. There's a lot of stuff in there, right? There's the major number, minor number, the UUID that I think is composed of things like the company code. I didn't see you guys talking about any of that either.
I see. So in general, with the Windows Beacon APIs, we followed the Bluetooth spec. So it's a universal beacon standard, right? And with that, especially with the major, minor, I didn't talk a lot about the other properties, but if you go in and look, there are a number of other properties that you can read off of that you'll get to see. So it's not, I didn't demo all of those functionalities, but they are there. I'm interested in what you're doing with this, so come by and see us outside in the Windows Insiders Lounge. I'd love to hear what you're doing with beacons, and we'll try and help you out and see if we can provide that functionality. All right, next question. I guess in the back, you were out there first, or?
Yeah, so for example, on Windows Phone, where your battery life gets a pretty significant hit from having Bluetooth on all the time, are you going to have a rate limitation on the background tasks, or?
One second, it's sort of hard hearing you from maybe, I think all I heard was that there's a power hit with the background task. Is that
so?
correct?
Are you going to have a limitation on how long a background task can run, or how many times it can get triggered?
Oh, so I mean, I'm not the best person to ask about background tasks in general, because that's just a general capability. I will say that there's work that had been done in Windows 10 to make sure your background task has at least 25 seconds, 25 to 30 seconds. One of the talks I linked to has more information about this. But these tasks for beacons are very short running, right? You want to get a beacon payload and then do something smart and quick. Send a toast notification to the user, ping up to Azure, things on that order. So I wouldn't expect it to exceed our system requirements.
Okay, yeah, just thinking that, for the example, when you're walking around in the store and you get a bunch of beacons and you're moving, it can get pretty messy with.
We recognize that, and there's things to do to optimize the background task. Oh, Alec, would you like to come on? Please do. I was like, here you go. Yes.
Yeah, it's wrapped underneath.
Okay.
You talk loud.
So I'll talk loud. So to answer your question, Kieran did mention that we have in the background task there's a periodic interval and there's a limitation of a minimum interval of 1 second. And so with the hardware offload, which will allow only the filtered results to event to the Windows system, Windows will stay in its lowest power mode until those specific events come up, and then there is a limitation of 1 per second. And the developer has control to expand that interval, so for something that they don't care about having it really reactive, they can also save more power by increasing that interval. And just to address the first gentleman's question about the format, the types that you were talking about are proprietary types for iBeacon. And so the watcher that Kieran showed is analogous to the monitoring. You can monitor for any beacon payload, and that payload can be a specific type, like the iBeacon type. So all those, you're able to do all those things. There isn't a specific.
Yeah, that's better.
Thank you. There isn't a specific ranging in terms of the buckets that that exists in core location. But what we do is we provide the raw SSI, so you can do that yourself. We are looking in the future at providing some sort of bucketing like that. But right now, what we've heard in general, like from our partners at Footmarks, is that they actually want the raw RSSI so they can roll their own and more improved ranging. And so initially, you can do that in your own app.
Thanks, Alec. Just keep this.
Are
Someone in the
these
back?
APIs going to be available for the Windows desktop apps, or going to have to be a store app?
Yep, it's a universal app, universal APIs, so you can enable them on desktop or phone, or embedded, anything.
Okay.
Sure.
I have several questions, actually. Is it planned to provide the ability to put several records into one payload?
Oh, would you mind using the front mic? I don't know why, the back mic is just a lot harder to understand up here.
If I use the publisher, will I be able to put several records into one payload? I'd like to have manufacturer data, short name, and several records in one payload.
Oh, so putting multiple packets, multiple data types into one payload? That's
Right.
the question. Do you want to take this one?
Sure. This is all documented on MSDN right now, if you go up to look at the API documentation. But for the advertisement publisher, currently, we're limiting the payload to manufacturer-specific types and also just a proprietary type. In the future, we'll enable more as part of, as we add more functionality for like GAT server. A lot of that information kind of suggests the existence of a Bluetooth LE peripheral with which you can interact, and that's not the case currently with Windows 10. We have an advertisement API to serve as a beacon, and then as we add more functionality, we'll enable more of those section types.
Okay, the next question, will it be able to set advertising and scanning parameters?
Like the interval?
Yeah.
No, Windows will advertise at 100 milliseconds.
Yeah, which is the fastest advertising
Yeah.
rate. So.
Okay. And the next is, we'll be able to use the watcher and the publisher at the same time.
Yeah, we were actually, I was actually doing that on the phone. I had the publisher going and the background watcher was also.
It actually depends on hardware ability of Bluetooth chip to be able to scan and advertise in the same time.
Yes, and that, I think that capability was in 4.0 already, and that was a requirement for Windows. It's a HLK requirement, and that's something that we test. So all of the partners that we, the major IHV partners that we work with are capable of doing that.
Okay, and the last question is, do you have plans to Bluetooth networking? I mean mesh networking.
So mesh is still something that's being discussed. There's no official spec for that yet, but that's something that certainly we're looking at. I think another gentleman has a question.
Yeah, we actually,
have
we're
one.
almost, we're pretty much out of time. We've gone into the red. So if you have more questions, please find us out in the Windows Insiders Lounge. We'd love to hear from you. So come and say hello. All right, thanks guys.
Thank you.
See ya.